Hey y'all, let's find out about invertible matrices. So I know we haven't talked a whole lot in class about what an invertible matrix really is, but I like to know. So I just put this up here at the top. So two things to know to start. A matrix is invertible if it's square, so the rows and columns are the same, 2 by 2, 3 by 3, 4 by 4, and if its determinant is equal to 0. So on Friday, I think we asked y'all a question, and I think literally everybody got it wrong, including me, except for one person, one student in the class, because everybody seemed to do the math right. We just got confused about this part. The determinant has to equal 0. Um, so we're going to look at this matrix right here to figure out if the matrix is invertible. So obviously we need to find the determinant of this matrix. So the determinant of matrix A is obviously going to be A times D, 7 times 6, minus B times C, 3 times 14. This is, for whatever reason, this example matrix keeps popping up. And so I know 7 times 6 is 42 and 3 times 14 is also 42. So the determinant of matrix A is, of course, 0. So is it square? Yep, it's a 2 by 2. Is the determinant equal to 0? Yes, the determinant is equal to 0. So yes, the matrix here would be invertible because of those things. You could also go into Desmos, type in right here, just type in the matrix, and I couldn't see it on the last video because I have a little bar for my XP pen that's covering it, but there's a button right here that says determinant, so you don't even necessarily have to type it in. Type in DET. You can just hit the button if you want, and look, boom, it tells you that the determinant of this matrix is equal to 0. Pretty cool. Hey, guess what? If we asked you to find the inverse of the matrix, you could do that for us too. Just kidding. Why isn't it doing it? Well, we're just gonna ignore that. I don't know. Undoubtedly, I'm doing something wrong. Anyways, so that's how you figure out if your matrix is going to be invertible or not. If you get a determinant that's anything but 0, then it's not invertible. All right, let me know if you have questions.